Okay, so today we're going to be focusing on two ways of managing collections in object-oriented programming and with specific reference to Java. Right, we're going to look on arrays and array lists. Now, the first thing we're going to look on is arrays, but well, maybe we should talk a little bit about the background to what we are going to be trying to do. All right, so in general, if you were to think about most programs that you write, you might end up wanting to store multiple items. Let's say you are writing a program to manage books. You might want to be able to store several instances of books. So a collection. And in that collection, you may want to be able to also do some things with that collection. Let's say you want to find a particular one, you want to delete, you want to add, you want to show all of those that are there. Now, in such a case, Java provides several different ways of doing so, of grouping objects together so that you can kind of treat them as one group or one set. We are going to be looking at lists in the forms of array and the array list, right? And these are what we consider the most basic structures. You will see more complex structures as you do more advanced courses in computing. All right. Now, importantly, array list allows you to store objects. Arrays allow you to store both objects and primitives, and we'll get to more detail on that a little bit later on. So the array list class, which is built into Java, it's a part of the Java.util package, so you'll need to include that if you are planning to use array list. This set or any object of type array list can store a variable amount of objects. So if you add one, it basically grows in size. If you remove an object, it shrinks in size automatically. All right. And incidentally, you can actually get an item from this list by using an index. Of course, index starts at 0, so the first item in that array list is always going to be indexed at 0. All right? And if you take away something from it, then it decreases the index, regardless of where you take it from, because the index represents those spaces that have values in them. Okay? So in Java, to declare an array list, you have to make use of the type or Java generics in order to specify the type that you are going to be storing in that array list. So if we wanted to create an array list that is able to store string objects or book objects or whatever the case is, then we have to make sure that Java is aware, right, of what we're trying to do. And so we would need to now indicate to Java, as we have done here in these angle brackets, the object type that we want to store. Yes? Now, and this, of course, is the name of the list. Yes? So we use array list, having included the Java.util package, we can use array list, and then an array list must be noted cannot store primitive types. What are the primitive types that you remember? Int, float, char, right? Those are examples of primitive types. You cannot store primitive types. If that is the case and you have a primitive type that you want to store in the array list, then you have to use the wrapper class, right? For example, for integer, for int to the integer, right? And so on, right? And once you use that, then you're safe. Now, to create an array list object, you need to, similarly to what you would have done if you were to create an instance of any object, you have to declare the reference type, object reference type, and then instantiate it. Now, you can do both things in one. So either you're going to say, as in the case as before, where you say array list, of course you need the angle brackets and the object type that you're going to store in the array list, followed by the name of the array list, as you would see here. And then you would need to do, you would need to now instantiate that list, right? That we just created the object type previously, and we need to say equal new array list, and we need to put back the type, and then the open and close round brackets because we're calling the constructor, right? It looks a little different, right? But remember, an array list can hold objects. We need to tell it what type of objects it's going to be holding, and so that is the reason why we need the angle brackets with the object type in here. Yes? Now, we can, of course, do the declaration and the instantiation in the same line just by doing array list, the type, the name, equal new array list, the type again, and then, of course, we're using the square bracket. Yes? Any questions so far? Okay. All right, so next thing we need to focus on is how do we add and remove things from our array lists. The important thing to note here is that there are methods that are provided in the array list class that allows us to do this relatively easily. So once we have an array list that we created here, right? So array list is word list, right? Right here. So we can now say word list, and we can use the add function with the dot operator, of course, and then we pass in an object of the type. Remember, word list was created to store string objects. So we basically pass in a string object here. I remember the string object is a special type of object that can be created by using the double quotes with a sequence of characters automatically. And that's just a special case in Java. All right? And all of a sudden, we will have a list that looks like this, right? With first in this position. And this is at index 0. All right? Now, we could add something else, right, by using a similar command with another input here. And you would realize that it basically appends the second thing to the end of the list. Yes? Now, the array list class indexes, I told you that already, that it starts indexing values at 0. So elements can be inserted and removed, and the indexes of the elements adjust accordingly. All right? Welcome, Barbados. Adding an item to the list. There's a second version of the add method where you can actually insert the item at a fraction. That was Barbados, right? Yeah. Right? So here we have an array list, which we can then use the add method. We tell it where we want it to be added and what is to be added, and notice it inserts it here in the list. All right? Now, getting an item from an array list, we use the get method, as you would see here, and then we specify the index of the item that we want to get, right? And it will return me whatever is at index I here, and that is, as we have here, is put into a string object called S1. All right? And of course, if you read the API documentation, you will realize that there are a lot more methods that are part of the array list class that you can use. And here are a few of them. You will note here that the specification speaks to no specific type. It's E, and then we have object. Now, because array list can store any object type, right? Whether you create an object or an object. So string, for example, exists in Java, but you could create a class of, called book and have book objects, right? You will note that Java doesn't specify specifically the object type. So you notice you see E here and OBJ, right? What that really means is that you have the option to determine which object you want to pass into the array list, but make sure that that object type is actually the same as what the array list is declared to hold. So if the array list is declared to hold books, right, then make sure every object you use with the array list where it requires an object to be used, it's a book object, all right, or else you'll get an error, all right. Now, notice here in the return type, this is a general type, and when we do inheritance later on in the course, you will get a sense of the class hierarchy of Java, and you realize that every type that you create in Java is really of type object, and we'll look at that a little closer. All right. Now, importantly, what you need to do from here on, we can't give you all of the details regarding array list, right? But the API documentation, which we introduced you to, I think 2 weeks ago, will provide you much support in that regard. Now, one of the important things that we might want to do is to be able to go through the array list from time to time to do some stuff. All right, and that really covers looping through, or what we call traversal. So one of the most common operations is to go to a list and apply or retrieve each object and perform some operation on that retrieved item. The simplest way to do that is to use a while loop or a for loop, right? In this case, we have an array list. Let's say we have an array list here with some account, right? And that array list is called list of account, right? Now, automatically, there is a method that we can call to tell us how many items are in list of account. All right? Notice it is telling us how many items, not the number of indexes. There's a difference. If there are 100 items in the list or 200 items in the list, then the indexes are going to be running from 0 to 1 minus the amount, the total. All right? So you would notice here, we say while I, which we start at 0, is less than whatever the size of the list is. So if the size was 30, then at 29 is the last time this loop is going to run. All right? It won't go to 30. And that will save us from having an exception, which we'll talk about a little later. Right? No such index. Right? So in this case, we are saying as long as I is less than the size of list of accounts being the array list, then we're gonna get the item at I. See that? We get the item at I, and I is going to be incremented each time from a list of accounts, and we put it into this account. And then we do this account that we draw 100, and then we print out the value of this account. And then we increment I. Notice here, what we're essentially doing is taking away $100 from every account inside the list of account arrays. All right? Useful kind of thing. Of course, this is a very simplified example. With us, Kevin? Yes?
For the most part.
For the most part. You'll catch it. All right. Now, sorting and searching, 2 things that are also important, right? Now, there are also methods that are provided that allow you to do these things. I suggest again that you see the documentation, and we will also do some of this later on in the course. All right, so now we have actually covered the array list class, right? Kevin, you'll get an opportunity to look it over. We were about 5 minutes into it when you came on, but I'm sure you'll catch it when you get the link for the lecture. So we're going to run into arrays, and also we're going to make some references here to array lists to make sure that you still understand the differences that are there between these 2 ways of storing items in Java. All right. Now, Importantly, array is a programming construct. There's a little bit of there's something really nice about arrays in Java that you might particularly like, all right? It operates similarly to how we treat any other object, but it's just an object that is able to store both primitives and objects in it, right? Now, it has a special syntax, and the underlying implementation is really what the array list class uses. But don't worry too much about that, right? Now, here's a comparison between arrays and array list. Very important, an array list is a class that is a part of the Java util library. Array is built into Java as a programming construct. You don't need to include anything, right, in order to access or create arrays. Array list grows and shrinks. With the arrays, it's a fixed size, right? You can resize, yes, but it's something you have to do manually. So if you want to change the size, chances are what you have to do is to create a new array, right, that is the size +1 or size -1 or whatever the new size is in order to get the change. Now, inserting an array list shifts the rest of the list to the right. So if I have 10 things in the list and I want to insert something at position 8, then the item at position 9 gets shifted down one place. Sorry, the item at position 8 gets shifted down one place to make space. If I try to do that with arrays, right, then it is going to override what is at position 8. So I will have to manually first shift down the item, right, and then put it in, right? So when I do an array list object and I say word list.add, it works it out for me. For array, if I assign something to an index, whatever is in that index is lost. So I have to manually make the space first, right, to make sure that we're fine. Now, very, very important distinction that so many students don't pay enough attention to. Right? Kevin, you with me?
Yes.
Good. You have to pay attention to the fact that array list does not store primitives. So the primitives such as float and int and char cannot be stored in an array list. You would have to use the wrapper class for each of those primitive types to make them into objects if you want to store them in the array list. Now the arrays can store both primitives and objects. So now when you are designing your application, you have to decide what it is that is most important for you. Do you want to be able to do the things that are important in relation to array list functions or arrays? So here's a nice reference table that I suggest you can always consult to make sure that you are on point, right, with which of the structures might be most important for what you're trying to do. All right, so let's look at arrays a little bit more. So an array is an ordered list, which means that you can move from one point to the other. They're not thrown all over the place. We know, for example, from level 1 computing, that a dictionary, for example, is an unordered list, right? But in Python, you know, vectors and lists are ordered, right? It doesn't mean that it's ordered by the elements that are in there. It means that you can move from one to the other and there's a particular sequence. Okay? Now, for an array, the first item is index 0. Just like the array list, right? So an array of size n has indexes from 0 to n-1. Very easy to figure out, right? Now, values held in an array are called elements, and I told you already that it could be either primitive or object references, and you know those could be any objects. Now, to create an array in Java, you first need to identify what type of data you're going to be storing in that array here. Yes, and then you write the square brackets as you have here, right? And then the name of the array. Okay? Everybody with me so far? So for example, if I want to create an array that can hold integers or ints, right? I put the type here, which is int, and then I put the square brackets, and then the name of the array, right? Now, the same thing happens if I want to store objects, book objects. I put the type, the object type, which is book, here, and then the square brackets, and then the name of the array, which is library. All right? There's another way to do it, and maybe C programmers prefer this way, where you can write the type of the items that you're going to be storing in the array, followed by the name of the array, and then the square brackets. Yes? And of course, this is what it would look like in real life to create an array. Now, inside here is where you need to now put the size of the array. Okay? But we'll talk about that. Now, notice that all we're doing here is declaring the array. To instantiate it is now when you need to put the size. Okay? So, we declare an array, that's what we get. Nothing. Just a reference. Yes? Now, if we want to say now, this array is supposed to hold me 10 things of type int, that is the time when we have to now instantiate it by using the keyword new, as with almost every other object. Yes? What it says that? Now, really and truly, the square brackets here, right, instantiates the constructor for the array. Remember the other cases we use the round brackets, right? So array is a special case. All right. Now note we can instantiate and declare at the same time by just using the first part, which is the creation of the object reference type, and then instantiating that. What is weeks? Gabriel? What is weeks?
62.
Weeks is the size of the array, but notice just above that line, we set weeks to something, right?
Yeah.
So you realize we don't have to put the actual literal value in there. It could be a variable that has a value in it that we use to set the size. So in one case we put 10, right? Which is the literal value. In another case, we put 1,000. In another case, we create a variable, set it to 52, and then use a variable here. We could also put an expression in here that returns us a value. Okay? So we could actually write in an arithmetic expression between there, but once it returns an integer value, notice that, an integer value. Not a double or a float or a character, an integer value. Because an array can have 3.5 spaces or indexes. Okay? Now, I told you this already that the square bracket is the constructor, all right? And we need an integer value, which could be either, as I said, a constant, which you insert a value, a variable, right? Or some expression that calculates and always gives you an integer value. All right? And here are some examples where we create arrays that hold different types. The first example actually does the declaration and the instantiation in one. Likewise in the second example, right? And then the third example, we break it up into two, right? 2 steps, right? And the third, we do it as one. Okay? Now, if we want to access the values in the array, we can just use the array name and the indexes, and the index where we want to access. So in this case, if we want to get the third value in the array, we write the array name, which is scores here, and then 2 is going to point us to the third value, because this is index 0, this is index 1, and this is index 2, and then 3. So the 2 here is going to point us absolutely to index 2 and not the second value. Please note that. Index starts at 0, so if you want the first item in the array, you need to point to index 0. Now, remember I was telling you that if you want to put something in an array, you have to make sure you create the space. So all of a sudden, if we did 89 is equal to scores position 2, 89 will be put into position 2 of scores. What is going to end up happening is that the value inside of position 2, which is 94, is going to be overwritten. See that? Now, note here also, if we have first been a value, let's say first is a variable that has, say, 5 in it, then automatically scores will get the value of first, so this becomes 5. And then we can say scores, it will get the value of 4, so this will be whatever is in scores position 5 plus 2. So let's say, based on what we have here, position 5 would have what value? This is 4, and this is 5. So position 5 will have 98. So this would be position 5, which is all of this will return me the value that is in position 5, which is 98. And then this will be 98 plus 2. So all of that is going to give me 100. So basically what I've essentially done is to add this to this and then put the result into position 5. So all of a sudden, my position 5 would have overwritten whatever is here with the new value, which is the sum of what was there before and what comes out. Question? All right? And the rest similar. Notice here, we say mean is equal scores position 0. So the item at position 0 is going to come out, which is 79, right? So this is going to be 79 plus the value at position 1, which is going to be what? 87. And then when it adds those together, right, it's going to divide it by 2. And then it divide by 2, and that's going to give you some average, and the value goes into mean. Yes? So that's accessing. Notice something here also, that we could write an expression, right? We could have an object called rand, right? That has integer values in it, and it generates, it takes the next integer, right, from whatever is passed in here. And basically, this statement is going to be generating a integer between 0 and 10. So the fact that we have 11 in here, yes, it's going to generate a value between 0 and 10. Now, whatever value it generates is going to now be that integer value here that tells you where in scores to take the value from and put into pick. I said between 0 and 10, that should be 11, sorry. Right? That's a correction. So, here's our array again, just from memory. I want to use it again. One of the things that I showed you with the array list was how to go through that list one by one and access each variable in that list and do something to it. Now, there's a special statement called for each that allows you to do that in Java. Now, pay attention to how this actually works. Now, remember, we have an array of what types here? The array is called scores. What are the types that are in this array, Barbados? Okay, Bill? What data types?
Integers.
Ints. Not integer object, but integer primitives, right? All right. So we have some primitives. Now, notice here that the for is going to be standard, okay? And this bracket. Now, this first item here must be the same as the type that is in the array. Yes? Then this here is the name of the array. Right? Everybody see that? Now, what this structure actually does is to go through the array item by item. So it goes through the array called scores, item by item, right? Starting at 0. So it opens up scores and takes the first item and copy it into this variable here. Everybody see that? So that it is now available in the body of the for loop. So we can print out score. Everybody see that? Then it goes back up and picks the second item out of scores and copies it into this variable again to overwrite what was there. And then now we have access in the body of the for loop to that second item. And it keeps doing that until it reaches the end. Now, this is a special construct that works. The most important thing to note is that the first thing inside of the brackets to the for loop must be the declaration of a type which is consistent with the type that is inside of our array. And then we have a colon and then the name of the array. And then we must be aware that whatever name we give to that type here, that variable is going to now be holding the current value based on the current index that we're at. So we can use it and do something. And in this case, all we're doing is printing it out. Everybody see that? Any questions, Barbados?
No.
All right, so we're all okay. Now, the only problem we have is that this structure or this statement cannot be used to update or to set the values in an array. It can be only used to access the values. Okay? So this special thing is not useful. Now, if we want to update values in the array, then we have to use the alternate while loop. All right? Now, here's an example of how we would achieve that. For example, we could set a start point and a stop point. Yes? But I put it to you that there's a special constant that is associated with all arrays that you create in Java that allows you to do something kind of neat. All right? Now notice we hard code the stop point, right? We set the stop point to 10. But we could also use the array name, which is what? Price dot length. And that tells me how many things are in my array. Okay? Now notice I did not put any brackets after the word length because it is not a method. It is a constant that is associated with each array that just keeps track of how many items are in the array. You with me? So I could have set stop to be equal to price.length, which is telling me the size of the array. Now, in this case, I start at 0 initially, and I say as long as the start is less than the stop point, what do? I take the item in price at the current position, which would have been 0, multiply it by 1.15, and then I overwrite whatever is in price at that position. So essentially, I am at position 0. It takes what is at position 0, multiply it by 1.5, and updates the same position to overwrite it. So the new value takes that place. And then I move on by adding 1 to the start. So start becomes 1. And I keep doing that as long as this condition is true. When that condition is no longer true, it exits. Okay? Now, here's an example of the use of a for loop here in Java. Not the for each. I showed you the for each already. This is a regular for loop where I create a variable index started at 0 and I say once index is less than limit which is set to 15, right? I keep adding 1 to the index and then I take whatever is at index and multiply it by some value and put it back in that particular location to update it. So that's just an example of how you would write a regular for loop. Now if you're not writing this for loop, then you can use the for each, right? But remember we told you what the limitations of the for each is for, not for updating, only for accessing. All right, and so you really need to know both. All right, and that example will produce some values which you will then go and try on your own. So here's a quick check. The first one is for your Barbados. I need to hear you contributing now. What would I write if I want an array that will represent the ages of 100 children? All right, that's your homework. All right. Ages are usually discrete values. So that's usually referred to as, well, the Americans do it, but I don't know if it's right. Somebody might say you're 9.5. But generally we say you're 9 or 10. They're integer values. So we create an array called ages and we set it to hold 100 integers, right? And then if we wanted to go through all of the values in that, then of course we use, of course, the same type that is in the array. This is the array, well, this is incorrect. If we were to use this, it should be ages, but in this case it says if the array is called values. So that actually corresponds. But if we wanted to do ages, then of course we would have int, and we could call it p. Doesn't have to be the singular of the name of the array, and then we would have ages, right? And then we have the for, yeah? And this is a colon, not a semicolon. All right? For that. And then the second one would be for the array named values. Okay? Now, it is easy for you, as you would have seen, to not pay attention to the number of indexes or the number of valid indexes in an array. And if you end up trying to reference a index that doesn't exist, then you will get what is called an exception. And the specific exception that Java will show you is called the array index out of bounds exception. All right. So Java has a mechanism for checking the boundary of your array. So if you try to access that index, let's say you try to access index -1, obviously that doesn't exist, you're going to get an array, an error. All right. Now here's an example of what we're talking about. Let's say we have an array called codes that can hold 100 values. That really means that I have indexes from 0 to 99. So if the value of count is 100, then the following reference will cause an exception to be true, right? Because I set count to 100 and then I pass count in here. So what is going to be in here is 100. So if I try to print out code's position 100, that doesn't exist. Yes? The other type of error that is common is what we call off by 1 errors. Yes? And students, please pay attention to this. Because in this case, notice where our problem comes from. We start at index 0, we're using our regular for loop. We start at index 0, and where do we stop? When index is less than or equal to 100. So when index goes to 100, we're going to have the same problem here, because we only have indexes from 0 to 99. So this should actually be less than and remove the equal. So index less than 100, which means it will stop at 99. All right? It's easy to make that error, and you're going to get your program crashing if you get an exception and you don't handle it. Of course, I'm going to show you in the next part of the lecture how to handle exceptions. Right? So, as I told you earlier, the array has a constant called length. It's not a method. The array list uses a method called size, and both of them basically tells you how many things are currently in the structure. So for the array list, you invoke the method called size. For the array, it is a constant. So for the array list, it's a dot size, open and close bracket. For the array, it's just dot length because it's a constant. Okay? Now, notice something, and we make a note here. Length holds the number of elements, not the largest index. All right? So that still will give you a problem, though, because if the array can hold 100 things and 100 things are in the array, then length is going to give you 100. But 100 is not a valid index. Right? But the constant length is a good way of not having to go and check through how many positions in the array is used on. It just carries that as a concept that you can use. Now, notice I showed you earlier how you create an array. Okay? I showed you how you access items in an array. I showed you how to put things in an array. But you can actually create an array and put things in it at the same time, right? By using what we call an initializer list. Notice a few things. We still carry forward the type. Yes? Right here? We still carry forward the brackets. But now, after the name, we say equal. We don't use a new keyword. We use curly brackets. And then we put each item we want in the list separated by commas. And when we're done, we put a semicolon. So automatically here, we don't have to specify the size of the array. The size is going to be assumed by the fact that we have that amount of things in the list. So in this case, the size is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you can do the same things you have done with every other array, right? It's just that in creating the type, right, we instantiate it with some values rather than instantiate it as an empty set of spaces to store values. Right? Now, I want to point out something specific to you here. If I have an array called my accounts, which is the last thing on here. So I have an array which is going to hold account, which is a object that I created, right? Remember the account object from last week and the week before, right? What I'm saying here is that I want an array that can store account objects in it, right? I'm going to call that array my accounts. Notice something here. I have now put two accounts in there, one here and one here, separated by a comma. You see that? But the most important thing is that these are object types. So I use the new keyword here. Have to use a new keyword for each object that I'm creating. Notice up here when I'm using primitive types, I just put the variable. Down here, I have to use the new keyword to basically say create an object type. And then, of course, whatever comes after the object type, the constructor here, has to match one of the constructors. So there must be an account constructor that takes in an integer value, for example, for me to do that. Everybody see that? Yes? Yes? All right. And that I just spoke about. All right, so that covers array lists and arrays. we're gonna take any questions you might have, and 2 minutes break. Okay, so we're now going to focus a little bit on an important topic, which is exceptions. Now, we're going to focus on handling exception because it is an important part of object-oriented design, or in general, when you're writing your programs, you must make provisions for handling things that we consider to go wrong. All right, so in computer science, a generic definition of exception is some abnormal or unusual activity, right? And this tends to arise during the execution of a program. So some things may happen that we don't expect, like division by 0. Others we might more than likely expect, like trying to open a file and that file is not found, or as I just gave the example, you might be trying to access a location in an array that doesn't exist, so you got the index wrong or something. And remember, when we write our programs, these values are not necessarily hard coded, right? Sometimes they are generated values, right? That are results of other parts of our program executing and generating some values and passing it around. So things can sometimes go wrong. Now, you think less of a programmer if every time something, a wrong input or something goes wrong, then all that happens is that the program just crashes and closes, and the user is left to wonder what went wrong. Right, Barbados? You wouldn't think I'm such a good programmer if my program behaved like that, would you? Now, the way how to prevent that is to use a mechanism that is available called exception handling. Okay? Now, Java provides a special class called exception that is used to deal with that. An exception is really an object that describes an unusual, erroneous situation, and it is created automatically when an exception occurs. You don't have to do anything to create it, really. So, for example, you may have had the experience running your code, something went wrong, and you see Java generated an exception in main thread X1, and it tells you the method and the line in which that error occurred. Yes? It happens. Now, what we don't want is for that to happen and our program to crash. We want to be able to catch that erroneous situation and do something about it, to improve the user experience, to prevent data loss, among a host of other issues that could arise. All right? Now, exceptions are said to be thrown by a program, like a child throwing a tantrum. Can't bother that, man. Right? But a good parent would usually handle it, right? So good programmers write code to handle exceptions. Yes? Exceptions generally will cause the program flow, control flow, to change. So when an exception occurs, it will move over into the exception control flow, and we'll talk about that, right? Now, depending on what provision you made for the exception, it could result in the program being terminated, or the method in which the exception occurred returning control to the previous method. And last week we showed you how that worked. One method calls the other, then that method calls that other, right? If an exception occurs in the third method, right, then it could return control to the previous method, and that method return, right? It could just end prematurely, or it could terminate everything and the program just crash. Or it could carry out steps that have been taken to recover from that exception. And that's what responsible programmers will do. All right, make sure that there's something there. So the Java API has a predefined set of exceptions that can occur during execution. And so these are named things that Java know can possibly occur. Now, a program can deal with an exception in one of three ways, as I said before. You can ignore it, you can handle it where it occurs, or you can handle it in another place in the program. Okay? I guess when you're designing your program, you can make those decisions as to what is most appropriate. All right? Now, if an exception is ignored by the program will terminate and produce the appropriate message. And I talked about that a little bit earlier, right? So here's an example here where there is a denominator and a numerator and some division going on here, and that will cause a division by 0, which we know is impossible. And so there will be an exception that is thrown here, and that is going to result in something looking like that. Ever seen that before, Barbados?
Yeah.
Yeah? Now, the good thing is that you can prevent this embarrassment, right? I mean, it reminds me of when Firefox crashes and it reopens and tells me that this is really embarrassing, right? Yeah, so that's an embarrassment for a programmer. So the mechanism for ensuring that we don't have that kind of, embarrassment might be the least of the issues. Because if you're running a program, if you have an application that is dealing with some important data manipulation, and something goes wrong in the middle of that, that would corrupt data, that would cause ripple effects in your application. Because that corrupt data could be used by somebody else. It could cause the connected applications to that, or the people who are depending on that to have a problem. Yes? Can you imagine you're in the middle of collecting some money from your ATM machine, and you put in your bank information and you press some values, and because you press the wrong grouping of values, it asks if you have 4-digit pin and you put in 6-digit. The machine just says, I don't know, process this and just crash. You wouldn't think much of the bank, right? You'd be wondering what else is going wrong. All of a sudden, guess what? You don't know if your account was debited or the transaction didn't go through. So what you have to do, you have to find yourself at the bank and find out what happened, or find yourself online to find out if you take out your money, right? And you didn't get it from the machine and so on. So you find the inconveniences, right, that will come if you don't write a program to handle these things. Now, a simple way to handle that is that if the person put in the wrong thing, right, is to say, wrong information received, please try again. Yes, which is what you generally see, right? Now, so then, how do you do that really in Java? And it's by using the try-catch statement, right? So, we oftentimes know when something can go wrong. And I will tell you that sometimes Java knows better than us. And Java will tell you that, hey, this statement that you have here can generate an exception. You have to handle it. Now, those exceptions are what we call checked exceptions. And that is because Java has built into it these exceptions that if these happen, it can mean something catastrophic. So you don't even allow your program to compile if you don't handle it. You with me? Yeah? Now the unchecked exceptions, you don't have to handle it, but you will still get a warning. Alright? Now, the way to deal with it, of course, is to use a try-catch statement. Now, what does that look like? It's basically using the word try, open and close curly bracket, and then you have catch, exception. Remember, exception is a class that exists in Java. So all you're doing here is creating an exception called E. Yes? Now, if this statement triggers an exception, it automatically instantiates E. You see that? And then you are able to now do something about that exception. You with me? So, if we know that a statement up here, right, could generate an exception called like a division by 0, we write it inside here, and then we say catch it, and when you catch it, then do these things. A simple thing could be ask the user to enter a different value, right, or just print out a message. and move on. Yes? Now, so the statement catch exception E means any exception. So the statement whether it generates an exception, which is an IO input output, a null pointer exception, or any type, it will handle it. Now, if it is actually necessary sometimes to specify the type of exception that you want to catch and handle them differently. Yes? So let's say a statement that you have can generate a null pointer exception, right? And it also could generate an index out of range exception. You might want to say to the compiler, if it's a null pointer exception, do this. But if it's an index out of range exception, do this. You get what I'm saying? So Java provides some predefined what we call subclasses, right? Which are all exception types, but they are more specific types. And we're going to talk about base class, derived class, subclasses, and so on when we do inheritance, right? But for now, just take what I say. So here are the specific types that you can actually zoom in on, right? There's a number format exception, arithmetic exception, and so on and so forth. You can look them up. Now, the try block is the try block has a set of statements. Within the try block is followed by one or more catch clauses. I was telling you about that. And then each catch clause can have an associated exception handler, which I just talked to you a little about here. So here's an example, right? We have two statements. So we have a while loop, right? And then inside that while, which starts here and ends here, right? We have a try. We have a statement here that can generate an exception, right? Now, there's an exception generated here if the code that is here, the character we're looking for at position 9 cannot be found. Or another way of saying is that this is an array that has some characters or a string, and we're trying to find the 9th character. Now, if the size of code is less than 10, right, which means that the last index is 9, right? It's less than that. Then there's no character at position 9, so that generates an exception. Yes. Now, this line here, integer that parsed in code that substring 3.7, right? If 3 and 7 doesn't produce a substring that can be converted to an int, let's say between 3 and 7 you have only letters, right? Then parse int won't be able to convert letters into an integer to put into this string. So I'm gonna get another exception. Now notice, I am catching what? A string index out of bound exception here and a number format exception here. So this one will generate a string index out of bound, and this line will generate a number format exception. Notice they're in the same try statement. So I can put as many lines of code inside my try. Yes? But in this case, it's not ideal to use the big E exception class. It's more ideal to use a specific exception, because the only way I can get a string index out of bound exception is from this statement. Because that's the type of thing that can go wrong. And the only way I can get a number format exception is from this statement. So obviously, if this happens, then I'm going to be printing improper code length. If this happens, I'm going to print district code. District is not numeric. So all of a sudden now, depending on what happens, I have a different response. Right now, Leaders? Yeah? Now, so I can have one try statement and as many catch statements as I have types of exceptions. Any amount. So if within the block that my try statements are, I have statements that can generate 10, 15 different exceptions. I can have just 15 catch statements to deal with each specific exception that can be generated within the try. And the code that I put in my catch is going to now be specific to the type of exception that I'm catching. Now, one thing you don't want to do here is to make your exception handling look like this situation here, where you're using exception here. Why you don't want to do that? Because any of the exceptions that would have been generated would be caught by using the exception class, because basically exception class is like the parent, right? So in a way, and I might be going a little bit ahead here, a string index out of bound exception is a type of exception. A number format exception is a type of exception. So basically, these two are more specific versions. You follow what I'm saying? It's like your name Smith, right? And all your family name Smith. But you have father Smith, mother Smith, son Smith, daughter Smith. Yeah? But if you're referencing the son, they are a Smith. The son is a Smith. The daughter is a Smith. The parents are a Smith. But then you can zoom in on the type by saying John Smith, and we know that is the son. Jane Smith, and we know that is the daughter. But there are more specific versions. But then you could say the Smith family. And so any one of them you see, you know says a Smith. So somebody can say, so one letter, give to the Smith family. So anybody you see, you give them the letter. But then you could get another letter and say, give it to Jane Smith. And that's a more specific version. You with me, my amigos?
Yeah, yeah.
Very important to note that. So if you're going to be dealing with specific exceptions, don't use the exception class. Use the more specific versions. So you can zoom in on the one that you want to handle and how you want to handle it. All right? So I told you that already. We can have as many catch clauses, right? Now, once you actually deal with an exception, then what ends up happening is that the code just continues. So if you notice, if this line, this strict line generates an exception, then what happens? It jumps and forgets all of the things that come afterward, jumps here. Yes, because this will generate a number format exception, deals with this and then goes here. Yes? So you have to be aware that the normal flow of your program is going to be disrupted if an exception occurs. Because when the exception occurs here, it doesn't do what is here, those lines. It jumps to where the catch is, does this, and then it continues down here. So guess what? You would lose these things. So you have to now be aware that those things, that is what is going to happen. Everybody with me? That's how an exception modifies the control flow of your program or the sequence of operations, right? And then there is the option of putting in what is called a finally class, which if no exception is generated, the statements in the finally clause are executed. It's always executed. So if you want something to always be done, once you go into the try block, right, whether an exception is generated or not, you want to make sure that it's done, right, then you basically can do that. And a simple example, for example, is where you want an increment to be done or a decrement to be done, right, whether or not the statement is executed. Yes? So in this case, maybe you want, you know, band to be updated. You could put a clause down here called finally, where even if an exception is done, is generated here or here, right? And you catch it and you handle it, it's always going to be executed, right? Now, when an exception occurs, you also have the option, well, let's put it this way. When an exception is generated, right, the exception is propagated back to the method with the try catch and handle there. So If it's not caught and handled where it occurs, it passes it back until it goes up the main. And if it's not handled, that's when the crash is going to occur, right? Now, let's look at this example where we put a call to level 2 inside our try statement here. And level 2 is a method that calls level 3 inside of it. And inside level 3 is where we have a possibility that a division by 0 can occur. Yes? Notice we handle the exception where? Where we have the level 2 call. And therefore, what will happen? The call to level 2, which calls level 3, right? Which has code that is going to generate the exception there. The exception actually goes back to the function that calls it. So it's not handled in level 3, but it's handled in level 2, right? Sorry, in level 1, which calls level 2, right? And that's where it's actually handled. Everybody see that? So the exception propagates from in the body of level 3 up to level 2, up to level 1, where it is actually handled. Everybody see that? Now, what that therefore, again, we said this is a design mechanism because you could always handle the exception where it occurs, which is right there. Yes? But in this case, we choose to propagate the exception up back to a particular point. Because it's like you want to say that if it happens in level 3, I want to leave, I don't want to move on, I want to go back to level 2 and go back up to level 1, where the problem occurs and do something about it there. All right? Depending on the design of your program. Nothing stops you from handling the exception inside the body of level 3. But maybe you don't want anything else to be done if there is an exception there. So you just stop everything, throw back to the previous program that throws it back to the calling program at the top of the hierarchy of methods that have been called. And that's where you deal with it. Where you can also go back through some process and do some other things at that point. That's a design decision. All right? And that's another example of well, that's what happens when we run the code. I'm going to encourage you, please, to take the examples at least that are in the lectures and those that we post online when we do post code and type them and run them for yourself, right? Because that is going to enhance your understanding, all right? We don't want to spend too much time going through the details of code. We just want to point out the key things. But it's for you to get your hands dirty and type up the code and see how things come together. Because we want to focus on the key areas rather than going through code line by line. Now, in some cases, I told you this already. In some cases, the compiler will give an error because a statement that can cause an exception is not included in a try-catch block. This will happen for some types of exceptions, and I told you that those are called checked exceptions already. All right. The programmer can choose to handle the exception if he or she knows that the method which the statement is being written has been called within a try-catch. So in such cases, the programmer can add a special clause called throws exception clause to the method, declaring to say that an exception should be propagated to the higher level. And what that really means is that it has to be handled further up. So here's an example of how we could do something. Let's say my method is going to be opening a file. And I have some code inside my statements here that tries to open a file from the disk. And that can generate an IO exception, which is one of the exceptions that are checked. So unless you handle it, you can't compile. You can basically tell the compiler that you know that there is an IO exception that might be generated here. And what you can do, or you can do that is by using this special line of code just using the word throws and the type of exception. You could also use the generate exception, right? Now, if an IO exception occurs within this method, it will return to the method that called it and will throw the exception back to that method. What that essentially means is that you'd have to handle it in that method. All right? Now, if you don't, then you know what will happen. All right? Now, in general, when an exception is generated, there's some data that is associated with it. Right? So, in our try-catch, notice we always instantiated, we always created a variable of type exception. So notice arithmetic exception, and that exception is called problem. Notice here, I have problem.getMessage. Problem.getMessage is a method that is in the exception class that returns me details about the particular exception that was generated. Right? And then I have the print stack trace, which provide a trace of all the method calls that led to that exception. So you can see which method called which one, and then where the exception occurred. Right? Kind of what you see on the screen in the program cache. Right? Now, that is useful, especially when you're debugging. Right? You can also see the details of that to be able to help you to figure out what's going on. And I told you about checked exceptions already. And you must either catch all checked exception, or you must list in the throws clause of any method that may throw or propagate. And the throws clause, I showed you how to do that a while ago. Now, you will get an error if a checked exception is not caught or listed in a throws clause, which means that the program will not compile. Okay? Unchecked exception should be handled, of course, but you will only get a warning. You can actually run your program if there is code that can generate an unchecked exception, but you'll get a warning. All right? There's another type of problem that can arise during your program execution, which is called an error, right? Error should not be caught, and they do not require a throws clause. I will show you the hierarchy of exceptions when we do inheritance. We'll talk a little bit more about you know, which classes are related to what, and what is an error and what is an exception, and how you get checked versus unchecked. I'll just show you a diagram, but we have to explain a little bit about how inheritance works for you to get an appreciation of that. Okay, so we'll just extend our discussion. All right, and maybe you don't know this because I didn't show you the hierarchy of exceptions, but just for your noting, like index out of bound and null pointer exceptions are unchecked along with arithmetic exception, but class not found and no such method exceptions are checked, which means that you can't compile without those. And it's easy to see why that is so, because if, for example, you have an array list and you're trying to run a method called simulate, and there is no simulate method associated with the array list, then you're going to get a no such method exception. Obviously, that's not going to work, so it don't make any sense to try and compile. So you realize that Java is really helping you to not go forward because it's too grave an error that is going to be generated. It's just not going to work. All right? And there are many others. Now, important to note is that in the creation of your program, you can actually create an exception class and throw that exception if something goes wrong. Right? Now, we're going to show you how to do that, but during the lecture on inheritance. But just know that, remember, Java automatically creates exceptions. But you as a programmer can create a class which is of type exception, right? And you can now have some code in your program that you say, anytime this happens, I need to create an exception. And you do that by using the throw keyword. All right? And we're going to talk about that in a little bit of detail, you know, in the weeks to come. Now, I want you to pay attention to this. If we have an exception being thrown, right, and it actually is executed, and notice there are three statements here. The statement that comes after that exception is generated is not going to be executed. So in this case, we have some code, print before throw, right? The throws new index out of bound exception is like Java saying there's an error, but in this case is we write it, we say throw this. So we say generate an exception here. Now whether we generate the exception or Java generate the exception, whatever comes immediately after is not going to be executed. It's going to be unreachable code. Okay? It's like having a return statement and then code after the return statement. Once that return statement is executed, nothing else below it is going to be executed. Okay? All right. So that's all I'm going to talk about for today. I think we did it in record time. I'm happy we were able to get through it. And so that concludes our lecture B. I'll take any questions you might have now.